Assalamu alaikum dear friends. Welcome to lecture of classical mechanics. In this we will discuss the solution for problem 7.8. In this, consider a region of space divided by a plane. We have a region of space which is divided by a plane. The potential energy of a particle in region 1 is U1 and in region 2 potential energy is U2. If a particle of mass m and with speed v1 in region 1 passes from region 1 to region 2 such that its path is region 1 makes an angle theta 1 with the normal to the plane of separations and angle theta 2 with the normal when in region 2 show that sin theta 1 sin theta 2 is equal to this, where kinetic energy is equal to this. The first we will draw a diagram so that we can illustrate it. If we look back to this is our region 1 in which the particle has potential energy u1 and this particle has velocity v1 which is striking at angle theta 1 with the vertical. Then it goes to region 2, this region. It's a potential energy u2 and it exiting with the velocity v2 with the angle theta 2 with the vertical. So we can write that potential energy u of x is equal to u1 if our particle is less x is less than 0, because on the left side x is less, so it is potential energy u1, and if this x is greater than 0 mean particle come in this region, it has potential energy u2. If we consider the potential energy as a function of x as above, the Lagrangian of the system will be, because particle has x1 coordinate and y1, so definitely its kinetic energy will be equal to m over 2 x2 dot k square plus y dot k square minus potential energy Lagrangian is equal to T minus U, as we know that. So our kinetic energy will be equal to m over 2 x dot k square plus y dot k square, and similarly we have potential energy, so Lagrangian is equal to T minus U. So we have potential energy and kinetic energy for the particle, so Lagrangian of the system will be equal to m over 2 x dot k square plus y dot square minus u of x. If we substitute this equation into Lagrange equation, it will give the equation of motion for the x and for the y. For the x, we will have Lagrange equation d over dt partial L over partial x dot minus partial L over partial x is equal to 0, and for the second d over dt partial L over partial y dot minus partial L over partial y is equal to 0. If we put this Lagrange into this equation, this will give this, and if we again put this Lagrange for the y, so it will give us another equation of motion for y, which is I think my double dot is equal to 0. Okay, so we again two equation of motion, one for x and one for y. Now we have to calculate the relation between the angles. So using the relation, we know that ma is equal to dp over dt, which is mx dot. You know that momentum force is equal to rate of change of momentum, F is equal to mx double dot is equal to dp over dmx dot. We can write this mx dot is as a p, so it will dpx over dt. If we use chain rule, so dpx over dx over dt, dx over dt, we know that dpx over dt, and dx over dt is velocity. So we can, if we multiply dx over dt here, as we know that this at this point we will multiply this with the dpx over dt. If we use chain rule, dpx over dx and dx over dt, so this is velocity, so it will become dpx over dx, and this is velocity. So if we multiply with mass and divide with mass, so it will become momentum dpx over dpx over dx. This is px over m. Okay, this is px. So we will obtain this expression by substituting because we have obtained expression for mx dot, we can substitute this mx double dot, which is equal to this term, into big equation which we obtained previously for m for x in this equation. So if we substitute the value of mx double dot in this equation, it will give us px over m dpx over dt plus dux over dt is equal to 0. Okay, up to so far. By integration between any two arbitrary point on the coordinate for x greater than 0 and another at x less than 0, so it will a to b px over m dpx over dx plus du over dx between the 2 points, because we have region 1, region a and region b. So we will integrate between the 2 points, the first for u1 and the second for u2. So integration between the 2 points will give us, if I maximize it, so it will give us px m is constant, it will come out in this integration, this m will come out, and this px has derivative in the front, so power will be raised by 1 px square over 2m as integration minus px square. And similarly for the potential energy u2 minus u1 is equal to 0. So we can separate it. We know that px square over 2m is nothing but kinetic energy. We know that if kinetic energy is equal to m over 2 v square, if we multiply this with m, so and divide this by m, so it will become m over 2 v square m over 2, I will write the m over 2 m square v square and divided by m. I have multiplied this m with m, so this m or m makes m square and v square, so it can be written as p square over 2m. So we can write this px square over 2m as kinetic energy, m over 2x1 dot square minus m over 2x2 dot square u1 minus u2. So for the second equation can be written as d over dt my double dot is equal to 0, and for the second equation evaluate this further, it will give my1 dot is equal to my2 dot, because dp over dy over dt is equal to 0. So by substitution back to this equation, if we substitute my1 dot and my2 dot into our previous equation, which is I think so, this equation, so it will give us mv1 sin theta 1 and mv2 sin theta 2. Thus if we evaluate this sin theta 1 or sin theta 2 is equal to v2 over v1, and we know that also we can write, if we multiply this 1 m over 2 y1 dot square is equal to, if we multiply this this equation with divide this by 2 and take, we can write it m by 1 dot square is equal to m over 2 by 2 dot square, which is very similar to equation result from the x Lagrange equation. By adding the two equations we get, if we add these two equations, so for the kinetic and for the potential energy, so mv1 square plus u1 is equal to mvt square over plus u2. Then v2 over v1 will be equal to 1 plus, if we obtain value of v1 over v2 in this expression, it will give 1 plus u1 minus u2 divided by kinetic energy. And we know that, so that we reach our target sin theta 1, because v2 over v1 is sin theta 1 over sin theta, here we have v2 over v1, so if we plug this equation into this, it will give us 1 plus u1 minus u2 over this, and this is sin theta 1 over sin theta 2 is equal to this. If this equations you look like these are the simple result we have manipulated, and our final result is this: sin theta 1 sin theta 2 is equal to 1 plus u1 minus u2 over t1.